Thank you for joining this lesson. Welcome for Physics Form 1 work, number 16. In an experiment to determine the density of sand using a density bottle, the following measurements were recorded. The first measurement is mass of empty density bottle, 43.2 grams. Mass of density bottle filled with or full of water, 66.4 grams. We have mass of density bottle with some sand, 67.0 grams. Then mass of density bottle with the sand filled up with water, 82.3 grams. Use the above data to determine the following. Part A, mass of the water that completely filled the density bottle. Remember, we have mass of empty density bottle, then mass of density bottle when full of water. That means mass of water can be determined, and this will be when we take mass of density bottle together with water minus mass when the density bottle is empty, then we will have gotten mass due to the water which is filling up the density bottle, 66.4 minus 43.2. This gives us 23.2 grams. 23.2 grams. The second part, which is part B, we are told to determine the volume of water that completely filled the density bottle. So volume of water that completely filled the density bottle is going to be given by, remember, density is usually given by mass out of volume. Therefore, from this, then volume will be given by mass out of density. So now we need a volume which will be given by mass, 23.2, divided by a density of 1, and this will give us 23.2 cubic centimeters. That is already determined. The next, part C, volume of the density bottle. So for us to get volume of the density bottle, then we need to know that because there is volume of water which is completely filling the density bottle, then that volume of water filling up the density bottle will be equal to volume of the density bottle itself. So we transfer that volume and record it as 23.2 cubic centimeters. That is something which has to be understood by every student. That's because water is filling up the density bottle and we know the volume of that water. Then that is the equal capacity of the density bottle. Mass of sand. Remember, we are already given mass of density bottle when it's having some sand and when it is empty. Therefore, for us to know the sand which is inside this density bottle, mass of sand, we record it keenly. Then we will be required to take the mass of density bottle when it is having sand, that is 67.0. Then we subtract mass of the density bottle when it is empty, that is 43.2. So when we carry out this computation, 43.2, I'm getting 23.8 grams. So that is the mass of the sand which is in the density bottle. We are also told to determine mass of water that filled up the space above the sand. Mass of water that filled up the space above the sand. So mass of water which is going to fill up, we're going to take a mass of water, show you, which is filling up this space will be given by, we have a mass of density bottle together with some sand as 67.0 let me not even start by writing this. When we fill up the density bottle with some water, the mass goes to 82.3. 82.3 grams. And when it was only density bottle and sand, the mass was 67. Therefore, we can get the mass which has been added here. That will be strictly due to the water which is filling up. 15.3. 15.3 grams. We want to know volume of the sand now. It's good we go systematically. Remember, in this case, we are having the mass of water which has filled up this density bottle. Now, because the density of water is known, we can know the equivalence of this volume. Therefore, we'll say volume of water, which is filling up is equivalent to 15.3. This is the mass divided by density of 1. This gives us 15.3 cubic centimeters. This is now the water which has been added up to that density bottle, which was having sand, so that it is now completely full. Can we talk about now the volume of sand? Volume of sand. Now, for us to get the volume of sand, now we will need to get the full volume of the density bottle, which is 23.2. Then we subtract the volume of the water which has been added to fill up. This will give us the volume for the sand, which is existing, 23.2 minus 15.3. This gives us 7.9. 7.9 cubic centimeters. So this is the volume of the sand. Volume of the sand, which is already inside the density bottle. Finally, we are told to determine the density of sand. Remember, for us to get density, we simply need mass out of volume. And for this sand, we had already determined its mass, and that was 23.8 grams. 23.8. Then now we have known its volume, which is 7.9. So this is going to be 23.8 divided by 7.9, and this gives us 3.01 grams per cubic centimeter. We can also talk of the SI units of density and have the density of this sand expressed as, when we multiply by 1,000, that is 12.66 kilogram per meter cubed. Kilogram per meter cubed. Thank you so much for following. Subscribe and share.